trig functions have an inherent geometry embedded inside them. To see this geometry, we'll define both the unit circle and then right triangles. Using both of these pieces of information, we'll define our trig functions based on them. In particular, in this section, we'll define the unit circle, and then we'll study its basic properties. There's two main ideas in this section, broken into three different pieces. The first one, what is the unit circle? And the second idea, what are the points on the unit circle? A related question to the second question that we'll be looking at in this section and the next one is, how do we find points on the unit circle? And it turns out we're going to need both angles and right triangles to determine this. Now let's define the main idea of the section, the unit circle. There's a few different ways to express the idea of a unit circle. One way that we could say what a unit circle is by the following. The unit circle is all points distance 1 away from the origin. Another more concrete way would be to say the following. The unit circle is a circle of radius 1 with center 0, 0. We can also express this as an equation given by x squared plus y squared is equal to 1. And to top it off, here is a sketch of our unit circle. With the first question in this section answered, let's look at the second question. Given some information, can we find a point on the unit circle? This will be example number 1. Again, we're given the following information. Find the missing coordinate. Of the following point that lies on the unit circle in the second quadrant. Then show it on the unit circle. Let's first sketch our circle. Here's our circle of radius 1 with center at the origin. And the problem is telling us that our point is going to lie somewhere in the second quadrant. We're given a piece of information, and that's our point is given by unknown in the x point and 1/3 in the y. And we have an equation for our unit circle. A thing we know about graphs is that if we're given a point on the graph, then this point must satisfy the equation of the graph. So if we plug what we know into this equation, then we should be able to solve for x. X squared plus 1/3 raised to the second is equal to 1. Simplifying this, we get x squared plus 1 divided by 9 is equal to 1. Solving for x, x squared is equal to 1 minus 1/9. Taking the square root of both sides, we're going to get that x is equal to plus or minus the square root of 8 divided by 9. Let's simplify this radical expression. This would then be equal to plus or minus the square root of 8 divided by 3. To determine whether our x value is going to be positive or negative, just recall again that we're given our point needs to lie in the second quadrant. So if this is if our x value is positive, this would mean our value would lie, our point would lie in the first quadrant. Therefore, our x value is negative, and then x is going to be equal to the negative square root of 8 divided by 3, which is what we see over here.